Hello, welcome to the Data Channel. So today, as part of the Databricks Certified Machine Learning Engineer Associate certification, we are bringing up the next video, that is data standardization, which comes under data preparation and feature engineering. So as part of the previous videos, we have seen the different data preparation techniques like data missing value, data imputation, data encoding, right? Similarly, we have a concept of data standardization. So this is also a step where you have to perform before actually running your machine learning models. So this is one of a critical step, crucial step that has to be performed before you actually kind of train your model or before you start using the models, different machine learning models. So in this video, we will see exactly what exactly the data standardization means and why it is important from the machine learning perspective and how to use it, why to use it, and when to use it, right? So if you stay till the end of the video, you should be able to understand this very clearly. And so before proceeding, if you're new to this channel, we recommend you to please subscribe and also press bell button for instant notifications. So let's get started. So as part of the standard course instruction, you have you can pause and take notes wherever it is necessary, because these are like there is a series of theoretical and practical concepts will be there. So please feel free to take a pause and take a notes wherever it is required, and also adjust the speed and volume accordingly. So you can to increase the speed, you can increase it to 1.2x, or to decrease, you can go till 0.75 speed, so that you can adjust your learning phase accordingly. And please watch a full video. And also, if you are intending to learn the entire machine learning, Databricks machine learning associate engineer certification, so please watch entire video and follow the entire playlist to get the maximum out of it. And also, there are some practical codes we will be running, so you can practice along with me so that you can learn much very easily and practically. And if you have any comment in the comment section. And if you require any practice notebooks that we are using in this particular course, you can send email to the email ID in the description. So with that, we will jump to understand what exactly the data standardization means. So data standardization is a process of transforming features so that they have been mean equal to 0 and standard deviation equal to 1. So that is the concept. So basically, we are rescaling the data here. So whatever data we are having, the features we are having, so this makes the features comparable and ensures that the scale of a data does not actually dominate the training. So you can imagine actually why the definition is fine, but you might ask the question, why are we really doing it, right? So imagine you have a five students with the marks that is 40, 60, 90, 70, and 50. And so what standardization does is it actually values are centered around the average. If you take average of this, it will be 62. And based on the 62, if it is around 60, then it is near to zero, almost near to zero. And if it is plus or minus, so then it can be plus or minus. So that is the standardization. Like it can go negative, it can go positive. So if it is, but the center will be revolving around the mean of the average, the mean or average of it, right? And why we are doing it? Like, let's suppose you are comparing the marks, okay, of marks of a particular students with their age, okay, or you are comparing the marks of a student with their sports performance, right? So in that case, you cannot compare. Like sports might be graded in a different level, right? Like individual who are playing in a sport, they might be graded 1 to 10, but who are actually writing a theoretical subjects, so those students are rated like out of like 100. Okay, so that is where if you want to compare students who are in the sports school, who are actually doing in the academics, so if you want to compare these holistically, so it cannot be done, right? Because there the scale is different, here the scale is different. So to bring both of these features into one scale, so that is where the standardization helps. So this is not basically just for one particular feature. So this is basically why we are doing this is machine learning. When you are using machine learning algorithms, they consider algorithms consider multiple features. That means multiple columns. They consider age, they might consider marks, they might consider the location, etc. Right? So when they are performing this kind of operation. So if there is a one feature, that is one column which is marks, right? So another column which is grade. So both has to be standardized to one scale. So if they, because grade can be like A, B, C or 1, 2, 3, 4, 5, and marks can be 0 to 100. So you cannot actually, the machine learning cannot actually compare these two. If it start compares these two, right? So then there will be a lot of biases or a lot of deviation. You cannot compare like 1 to 10 score with 1 to 100 score. So there will be a lot of deviation. So that is where the whole intention is to bring these kind of multiple features into one scale, so that machine learning algorithm will can take a better decisions based on that. So that is where you are rescaling the data. So the scale was 1 to 100, 0 to 100 here, but now you are making it to a particular scale where you are making mean as zero value, and it can go plus or minus. Similarly, if there is any other value like 1 to 10, you are getting value. So you can take again the average or mean of that. But ultimately it will fit in this scale. So that feature also will fit in the scale. So that is the whole intention of standardization. And when we need it, right? Basically, so it might not be every time needed. So it is needed where you are performing a logistic regression, right? Linear regression and SVM support machines, right? And K nearest neighbors and principal component analysis, and you are having certain neural networks based operations. So then you might actually need to perform the data standardization, right? So otherwise, there are some decision trees, some other neural network based algorithms like decision trees and etc. So there you might not need the data standardization. So that we will see in detail in upcoming slides. But what exactly important here is what is standardization and when we need. These are the cases like where you think these machine learning algorithms you are planning to use. In that case, you should be kind of thinking of standardizing the values, right? So now we will see standardization versus normalization. So because often people will get confused, or people when they think of normalization and standardization, but first thing to notice the normalization in database is different, right? And the standardization in data modeling is different. So whatever standardization or normalization we are talking about, this is predominantly or particularly from the machine learning point of view. So machine learning point of view, normalization, what normalization means and what standardization means. So standardization means, as we saw, right, we are rescaling the data to have mean equal to zero and standard deviation equal to one, and values can also be negative. So that's what we have seen. And normalization, it actually puts it to one box. So that box can range from 0 to 1. So it has the like that scale or the boundaries already set. But standardization doesn't have a boundary. It can start with 0, it can go to right side, and it can go to the left side. But normalization has fixed the range between 0 to 1, and all the values, it might be any thousand number of values, so it will fit those values in that 0 to 1 scale. So that is a normalization. So use standardization when data is actually normally distributed, and normalization you need to use when you want like bounded values like image pixels, scaling, etc. But the main thing here to notice, always fit like scalar on training data and then apply to test data, so to avoid any data leakage. And outlier can distort mean and standard deviation, so consider robust scalar in such cases. So with that, we will see a particular example of how the standardization can be applied or mathematically, right? So mathematically, this is the standard. This is the standardization formula, and here z equal to x minus mu divided by sigma, what you can call, right? So here x is actually original value, and then minus mean of a feature. So you are taking a mean of a feature, and then mu symbol that you are using here. So it can be a standard deviation of a feature. So that is where if you have like suppose you have a salary of employees, right? So you, all of this like 12,000, 25,000 is all of the salaries, for example. And you will take a mean of all this salary, which comes around this value, 52,833. And then you divide that with the standard deviation of the features. So that is where you arrive to a standardized value. So this is how the standardized value looks like. So before the values are like 12,000, 25,000, 40,000, etc. Right? But now the standard after standardization, the salaries will look like this: minus 1.3, minus 0.3, etc. So it will it can range from like zero, it can go to negative, it can go to positive to any extent. So it can be minus 1 or minus 10, minus 20, right? It can, or it can go plus 20 also. So, but there is no like a boundary, but it starts with a zero, which is a mean here. So that's where you see here the standard deviation, standardization, right? So it is going towards the like plus and minus both the sides. And the actual data was like this, right? So actual data was actually all in the X and Y axis. There is no negative. All was all over the positive values, salaries. But now after you apply the standardization, so it looks something like this because you are seeing a negative values as well. So, and other side, you have normalization. So in this, actually, you have the formula that is x minus x min divided by x max minus x min. So here, if you say, if you take again the same salary as an example, so here it is taking the x min. So x min minus x min, right? So this is x min and divided by x max minus x min is 88,000. So finally you are arriving to a value which is a positive integer, or it can be zero. So it can range from 0 to 1. As you can see, the minimum value will be 0 and the maximum value will be 1, and rest all other values will be between 0 to 1. So that is where you see here normalization. So you have a 0 to 1 scale here. All the values are fitting in that 0 to 1 range. So it is quite important to understand the difference because most people get confused. So you can use either of these, but standardization is mostly used, and like you can standardize or normalize the data accordingly. But standardization is most widely used. Next, we will see the benefits of standardization, what exactly we are getting out of standardization, right? And so first is fair comparison of features. Like suppose we are predicting health risk using like weight and height. So if you want to predict a risk of like getting any disease or any health related risk calculation you're performing, so if you're comparing health, which is like health using height and weight, and height will be usually in like let's say it will be centimeters and weight will be in kilograms. So like using these two features and trying to make a relationship out of it or having that comparison is not fair, right? Because they are not in the same scale. So without scaling, a 50 centimeter difference in height looks way bigger than a 10 kg difference in weight. That's why, like model thinks, height is more important just because of bigger numbers. Um, so that is where it is like after standardization, both are converted into same units, like considering mean as zero and standard deviation as one. So now height and weight contribute fairly to the model performance and model predictions. Like and the other thing is, so as you can see here, before height and weight was not normally not were not in the scale, but after that it after normalization, so it came into that particular scale or normalization or standardization, it came to that 0 to 1 scale or 0 to like minus 1 or minus 2 scale, but ultimately you see here, so both are came into a same scale after that, right? And so you also have a improved performance, model performance, like using like say KNN, K nearest neighbors, to classify people. So feature one is age, which can range from 20 to 60. Feature two might be income, which range from 10,000 to 1 lakh. Without scaling, distance calculation is because KNN is majorly a distance calculation based model. So without scaling, distance calculation is dominated by income because that looks bigger than the age, right? As a numerical value. So age barely affects neighbor selections and it might lead to wrong classifications, right? But after like you start using the standardization, both the age and income are will be definitely coming into the same range or scale. So now neighbors are chosen fairly, and model accuracy also improves significantly. So that's the whole idea here. Okay. And also you have a faster convergence. That means like if you're training a neural network with the features, like feature A values can be 0 to 1, so which is normalized, and feature B values is 0 to 1,000, which is a raw value. So without scaling, what happens is like you have a gradient descent takes huge uneven steps. It can lead to a zigzag path. So training will become very slow, or it might also fail to converge. So after standardization, both features have zero to have mean equal to zero and standard deviation equal to one. So that will definitely lead to the smoother optimization path, and model will also converge or perform better and converge better. So this is basically these are the the perform the standardization benefits of using standardization. So next, we will move to see which we are using model sensitive feature. We will see which are the models which are sensitive to feature scale and which are not. So this understanding will help us whether we really need to do a standardization normalization, if at all, or we don't need to do this, because standardization is not a mandatory step. So it depends on which machine learning models that you're using, and whether these models that you're using are scale sensitive or not, feature scale sensitive or not. So that we will be seeing here. So based on that, we can conclude that whether the standardizations is required or not. Okay. So if you see here, we have these models rely on, like say, like whatever you see on the left hand side, these are the models which rely on the distance, dot products, or gradient descent. So large feature value can actually dominate the dominate, and other can be ignored. So that is why it is these models, whatever you see on the left hand side. So these definitely are sensitive to the feature scale. Whether it is a k nearest neighbor, k means clustering, SVM, support vector machine, and logistic regression and linear regression, and if you are having neural network and deep learning, so all these models are very sensitive to the scales. So if there is a variation, or if there is a sudden feature differences, right? One is 10 and other one is like 1,000 or 1 million. So suddenly they will start showing the performance implications, or the performance implication, or the model might not perform the way you are expecting, right? So that is where, so when you are using you are having the plan to use these models which are very sensitive to the feature scale. So then definitely you have to perform the data standardization on the features that you are targeting on, right? And however, on the other hand side, if you talk about decision trees, where splitting, like these are like mostly the models which are tree based or rule based. They split based on the threshold, not the distance. So they are not distance based. So they work on a splitting basis based on the threshold. So if there is a particular range, so they will start splitting the data. Like if you take a decision tree, for example, so it split uses conditions like if the age is greater than 30, you are in one bucket, age is between 30 to 40, you are in another bucket. So here actually the scale doesn't matter. So scale or the volume of the integer or numeric value doesn't matter. And also the random forest, which basically collect is a collection of decision trees. So here also it will not be, these are also not impacted or affected by the feature scales. And gradient boosting, so there are gradient boosting gradient boosting models. So these are also like almost the tree based, and these are also not affected. And naive based. So this is works with the probability and ratios. So the scaling is not much of a critical here. So these are the cases where you can clearly understand where the standardization might not be really required, because standardization also it takes some performance, or it takes some time to run. So, and also it might be unnecessary if you are running. You might land up running it unnecessary if you are choosing these right hand side models, right? So these models, if you are using, so then standardization is not a mandatory step. But yes, so if you're using these models which are in the left side, which are mostly mostly rely on the distance based and the gradient descent based. So in this case, you should be still using the. So you can have a quick analogy also, right? Like sensitive models, like you think about a model is there, so which is trying to measure the distance between cities. So you need to like you need to have the same unit like kilometer, miles, etc. Right, and you need to like that will be very sensitive if not. So that is a distance based, right? So where you are predicting those kind of scenarios where you are thinking distance between cities and distance between like the performance between the like individuals, etc. Right. So if you're having that relative scales where you're trying to perform relative based, distance based, so then you will be using mostly these left hand side models. So then it is quite sensitive. So you need to perform the data standardization. But if you are using, like say for example, insensitive models, and these insensitive models, when I say insensitive for feature scale, right? These like asking like temperature is temperature above 30 degrees Celsius, or is it hotter today, or is it warm today? So it is like it doesn't need a unit. So you just need to say whether it is, you need to predict whether it is a hot, warm, or lukewarm, whatever, right? So that doesn't need sensitivity, doesn't have any sensitivity, and doesn't need the data standardization. So with that, we will go to the next one and see steps to perform the data standardization. What are the really the steps that you need to follow so that you can have the standardization implemented in your project, right? So first thing is definitely you need to have the access feature distribution and scale. So this is basically what you're doing here is you look at each features, that is range, unit, and variance. Example, if the salary is in lakhs versus age in years, so these are two different features and very different scales. So then you need to decide if standardization is needed. So if you usually yes for the distance gradient based, right? So then you can decide the standardization is required or not. So basically what we are saying is, first thing is there might be multiple columns. You need to identify which columns you are using as a features. So those columns, if they are in different scales and intention is to perform gradient descent kind of or distance based models, so then you need to standardization, and then only you need to go to the step two. So step two is more of a data preparation. You prepare, that means you split the data into train, validate, and test sets. So train is basically model learns the pattern validation used for as a like a tuning parameters or hyperparameters, and test is like final unbiased evaluation. So what's important here is never standardize before splitting. So you need to split the data first when you're so you need to split the data into train, validate, and test into three different. So there's a 60-20-20 what we talk about. So that we need to split it, okay, and then you need to perform the standardization. So before that, if you perform standardization, it might not it can have a data leakage. So that is why it is best to first split the data into multiple three parts: train, validate, and test, and then after that you apply the standardization. So the third step, what we can talk is like create and push feature store test. So this step is actually not mandatory, but it is recommended in some cases. Like you want to store raw and transform features in a feature store. Basically, the intention is to reuse. For example, instead of recalculating every time, you save the standardized versions like salaries, their age, height into a shared store. So that actually helps in consistency across like different training and inferences building inferences pipelines. So next is the last step where we talk about a build standardization pipeline. So here we need to use standard scalar. So this is like in the code we need to use standard scalar or custom logic. So in the upcoming videos we'll see in the practicals what is standard scalar, and also you need to fit only on train. That means you need to learn mean and standard deviation from training data, and then apply the same transformation to validate and test. That is important. Okay. So this is basically the steps, the number of steps, or the sequence of steps you can follow to implement the data standardization. So next we will jump and understand what are the key drawbacks. So definitely data standardization also has a drawbacks. Okay. So one is the loss of interpretability. So what happens is there might be raw data which is like a salary which is 1 lakh or a age equal to 45, which is quite intuitive, or like any layman can understand, or any business can understand that salary is 1 lakh or age is 45. But after standardization, you will see the values like minus 0 0.8 or plus or 1.2, so which actually don't carry any meaning for the business. And if you're talking with the business, or you are kind of a convincing business, or you are interacting with business, so then the interpretability with this data will be lost. So that is one of the key important thing. So this is where I was talking about the feature store. So you need to store these features in a store so that you can reuse that. You can take help of that feature store when you're talking to business about this, or when you're talking system by understanding these values. Otherwise, the actual values might get lost, and you end up having the values which are very difficult to interpret. And next is assumption of like normal distribution. So basically, standardization is done with assumption that the data is normally distributed, right? And standardization works best if data is roughly like Gaussian or bell curve, which is a sign of a good normal distribution, right? But if data is highly skewed, okay, or like has a heavy outlier, so then mean and standard deviations get distorted. So then it might lead to a misleading standardized value. So this problem might occur when you are already, like say, deploy the model into production, and then the values might be coming which are basically the noise, or some data, some genuine data also, so which might be affecting this normally distributed values, right? And it which might not fit as a Gaussian or bell curve. So then definitely it would like because it might not be a normal distribution, it is no more a normal distribution, so then it might impact the overall model performance in that case. And it can create a misleading standardized value, because there might be huge variations up and down. So it can that is another problem. And next is sensitivity to outlier. So what that means is a single very large or very small value that can like significantly shift the mean and the standard deviation. So that possibility will always be there. For example, you have a salary like 50K, 60K, 70K, and then another person is having 5 crore. So after standardization, almost everyone look like minus 0.9. So except the outlier. So that is why it is like that's what we were telling about the normal distribution. The data should be normally distributed. If there is like significant sudden spikes, so again this is a it might create an outlier, and it might become a sensitive to the outlier, and then finally it is impacting the standardized value itself. So then you have a pipeline complexity, right? So you must fit a scalar on train only and apply it to validate and test. If mistakenly applied before splitting, you leak the information from the test, inflate the performance metrics. So this will definitely add complexity to the machine learning pipeline, especially in production with feature stores. So these are the like a few drawbacks or limitations of data standardization. But again, so these are like not comes by like nature. So this is basically it comes by the nature of the data, and how the data is changing. So you need to keep monitoring the data, and see for any abnormalities or any outliers coming in. Otherwise, data standardization is a must operation, and you need to perform because of there is a lot of advantages that we have seen. And definitely when you're using the like distance based machine learning algorithms, so definitely you need to standardize your data. So with that, we have reached the end of this particular topic, that is the data standardization. So hope this was useful. And if it is useful, please like, comment, and also subscribe. But if you have any suggestions, or like any feedbacks or any questions, please feel free to comment in the comment section. Thanks for watching.